Need some reverse psychology. Okay, Ricky, don't follow along and don't take notes on this, okay? I don't want to see any notes in your notebook. Okay? Make sure you listen to me.
But what if he takes your words against you?
No, he won't.
What you said
He always
no.
does the opposite. All right, we're starting with an easy one. You could probably solve this in your head, but we don't do that because we show all our work. So how do we solve? It says solve the equation. What do you mean solve the equation? What are we solving for? X. Very good. But aren't we doing quadratic equations? That doesn't look very quadratic to me. How is this a quadratic equation? It does equal 0, and yes, quadratic equations are set equal to 0, but that's not what makes it quadratic. What makes this actually a quadratic equation in disguise? What? What makes a quadratic equation quadratic? What does it have to have? What? No. So that is the standard form. Technically, a quadratic equation does not have to have all of those in order to be considered quadratic, but you did say one specific part of it that has to be included in order to be considered quadratic. X squared. The degree has to be 2. Very good. If it has a degree of 2, it is quadratic. So, does this have a degree of 2? I don't see any 2's. If you were to FOIL it, yeah, we would do x times x, which gives us x squared. So this is quadratic. It's just a factored quadratic equation. It's already factored for us, which makes it really easy to solve. Tell me why, or explain how the zero product property will be what helps us solve this. You can kind of explain what the zero product property is. What do I mean when I say zero product? Yeah, well when I say, yes, very good. Zero product property means 0 is the product. And the property is basically saying that in order for 0 to be the product, at least one of the, use the correct word, starts with an F, factors, at least one of the factors must be what? At least one of the factors. In order for the product to be 0, at least one of the factors has to be 0. How do we apply the zero product property to solving this? What can we do? I want to know what the x values are. How do I use the zero product property to figure it out? It says that that 0 is the product. That is the case here, right? And then that means that at least one of the factors must be 0 or must equal 0. What? No, it wouldn't be x that's 0. Set what to 0? I know what you're saying. Equation isn't the correct term because an equation, the equation is the whole thing here. Did you mean? Yeah, the factors, or you could say the expressions x plus 4 and x minus 9. We would set both of those equal to 0 because if this factor here is being multiplied times this factor here to get 0, that means either this is 0, or this is 0, or both of them is 0. So if that's the case, we need to solve for x as if this factor is 0. So x plus 4 is 0. So what's x? Negative 4. And then on the other hand, there's another x value that would cause one of the factors to be 0. How do we find out what it is? Set the factor, the expression x minus 9 equal to 0, x equals 9. Explain to me why I'm getting two different values for x. Different numbers. What do those solutions look like on a graph? The parabola thingy?
Yeah.
Tell me what about the parabola we know because of these solutions. Well, the parabola is happy, but it's not because of the solutions. The parabola is happy because it would be x times x is positive x squared, positive 1x squared. So that makes the parabola happy. But this has nothing to do with whether the parabola is happy or sad. But I like that you're checking in to see how the parabola is feeling. It's always good. They appreciate it.
Is it because it intersects like both sides?
Yeah, it intercepts the x-axis in two different places. It intercepts the x-axis at negative 4, and it intercepts at positive 9. So this would be a point over here, and then a point over here. That's quite a wide parabola. Now we totally could figure out the vertex, but we don't have to. We just know that the parabola is happy and that it is intercepting those. So I don't know where the vertex is, but I don't know. Let's just say it's like that. Who knows? We just know that it intercepts here. It has an axis of symmetry, which we could also figure out, but we don't have to. So let's not. If you want to make sure that the solutions that we got, negative 4 and positive 9, if you want to make sure that those solutions are actually true and we did it the right way, just plug them in. Negative 4, if you plug that in for both x's, we get negative 4 plus 4 times negative 4 minus 9 equals 0. I've got good news for you. If this ends up working out to be 0, then it doesn't actually matter what this one is, right? Because this literally could be any number, and you would get 0, which would just make it true. I mean, you could. This does equal negative 13, but it doesn't really matter what it is. As long as your negative 4 causes one of your factors to be 0, then it is a solution. Now let's try the other one. The other x value is 9. So if I plug that in, I have 9 plus 4 times 9 minus 9 equals 0. Oh look, 9 minus 9, that's 0. So this literally could be any number. Doesn't matter if it's 0, negative 5, 12.3, doesn't matter. It's 13, but it doesn't matter because it's being multiplied times 0, which means that the product is going to be 0, which means that it works and it's true, which means that these solutions are correct.
So how do I type this in?
Type what in?
Negative 4.
So we're going to read the instructions. It says the solution set is, it says type integers or fractions. We don't need fractions because we have integers right there. Use a comma to separate answers as needed. So all you have to do is type in both of these numbers. Oh, does it want you to type it in as x equals? No, you just type in the numbers? Okay. This is kind of weird though, because it's asking you to write it in a different way. Because on the homeworks before this, it would already set up x equals, and then you just type in the number. So it does look a little confusing with those brackets. So just negative 4. work of the way there. And something up. There we go. Uh-oh. Why is this looking weird? What's weird about this?
Because this X is a coefficient.
Huh?
The X has a coefficient.
That is a little weird.
And they're squared.
Yeah, this factor is being multiplied times what to get 0? No.
By itself.
It's being multiplied times itself. So this factor, 7x minus 9, is being multiplied times itself, 7x minus 9, to get 0. How do we use the zero product property to solve for x?
Just set it.
They're just staring at me. Use the same thing that we just did.
Just set it.
Set them equal to 0. Now, you could set both of them equal to 0, but do we really need to?
Yeah,
Why not?
because
They're exactly the same thing. You're gonna get the same answer. I'll prove it. I'll set both of them equal to 0. 7x minus 9 equals 0. 7x minus 9 equals 0. We're gonna do the same thing to solve for x on both. You're gonna get the same answer. Plus 9, 7x equals positive 9. What do I do from here? Divide by 7. Divide by 7, I get x equals 9 over 7. Improper fraction, who cares? It's a fraction, it's a number, it's a value, it's a solution. Should we solve this one now and see what we get for x?
Yeah.
Really? Really? Okay. Can anybody tell me what to do to solve for x?
Plus 9.
Zach can't. Say a nap. Plus 9.
Huh?
It's okay, Zach. Now what? Abby, what do we do next?
Divide.
By what?
7.
Good. X equals 9 over 7. Same thing. It was funny because like in my first period when we were doing problems like this and I was coming around to check answers, they got a question like this and they would circle both of them and show me both as the answer. I was like, that's great. It's the same thing, so it's really only one solution. I just thought it was funny. So when you type this into the answer, do you need to write 9 over 7, comma 9 over 7? No, because that is just 1 point on your x-axis, which also happens to be the length of the parabola. The what? Yes, how do we know that this is the vertex? What?
What are you pointing to?
I'm not pointing to anything. 9 over 7 is the solution, not the solutions. It's just a solution. One single solution. So, how do I know that it's where the vertex is? 9 over 7 comma 0. How do I know that that's the vertex of the parabola? In the previous example, we didn't know what the vertex was unless we solved for it, which we didn't. Can anybody tell me how I know that this solution, not solutions, that this one single solution is the vertex of the parabola? Ricky, you know this. What? Because there's only one solution, right? If there's only one solution,
There's 2.
no, it's the same number. It's the same point on the x-axis, 9 over 7, 0. What?
I thought you were counting them as 2.
No, I was saying how it was funny in class that they circled both of them as like they're both the answer. It's like saying x plus 1 equals 3. x equals 2 and x equals 2. And x equals 2 and x equals 2. It's the same thing. So we don't need to write it over and over. It's one solution. If it's one solution, that's where the vertex is. Just, I don't know, I just thought that would be an interesting question. Oh my goodness, solve by factoring. I liked it better than when they did the factoring for me. Can we factor this? No?
Yes.
Yes? Let's do it. How do I factor this quadratic equation? We're gonna have to go back like, I think it was topic 7. I probably should know. I think it was topic 7, right? When we factored quadratic expressions. Let's factor the quadratic equation. We're gonna break it down into 2 binomial factors, and it's going to equal 0. How do we do that? Abby, Callie, Ricky, you already had the lesson today, so you guys, it should be fresh for you. Yeah. So I need to find 2 numbers that multiply to get what? Negative 15. And that add to get positive 2. So I make my nice long boxes so I can do a couple of pairs to get negative 15. So I could do negative 3, positive 5. I can do positive 3, negative 5. I can do 1 and negative 15. I can do negative 1 and positive 15. Which one of those pairs will add together to get a positive 2? Do you guys understand why I listed all of the possibilities to multiply to get negative 15? 15 is a pretty easy number because it doesn't have a lot of factors. It just has extra pairs because I had to account for, well, this could be the positive one, this could be the negative one. But only one of these pairs will add together to get positive 2. Emily? Negative 3 and positive 5. Very good. When I combine these, I'm going to get a positive 2. So that is how I know what numbers will go here. But does it just go like this, like negative 3 and positive 5? Negative 3 times 5 is 0? No. What does it look like here? What do I write inside these parentheses? For the binomial factors. What does bi mean? 2. Binomial meaning 2 terms in each one. Yes, p would go in both of them because p squared broken down into 2 factors would be p times p. Okay? And then what would I have? Yep, negative 3 and positive 5. That's it. Now I have my factored form of the quadratic equation. Now what do I do?
Use the zero product.
Yeah, use the zero product property. P minus 3 equals 0. P plus 5 equals 0. And I'm going to let you skip the whole add 3 to both sides. I'm going to let you just write P equals what? Huh?
P.
P equals 3. P equals negative 5. If we wanted to check our answer before putting in those numbers, what should we do? Plug them in. Let's plug them into this original equation because if I factored wrong, it might work for this, but it wouldn't really tell me the truth about whether it's right or not. I have to plug it into the original equation. So p squared plus 2p minus 15 equals 0. both of these numbers have to work for P and make this true. That's the only way that I can say that those solutions are correct. So I'll start with my positive 3. I'm going to put it in for P, so I'll have 3 squared plus 2 times 3 minus 15 equals 0. 3 squared is?
It's
9 plus 6 minus 15 equals 0. 9 plus 6 is?
15.
Minus 15 equals? 0. It works. Now we have proven that 3 works. Now let's try 5, or negative 5. I'm going to make sure to put a parentheses here for my negative 5 to show that negative 5 is being multiplied times itself to get our answer here. So what do we get here?
Oh, negative 10, not negative 10.
25. Negative 10 minus 15 equals 0. 25 minus 10 is 15 minus 15 is 0. Both of these numbers work. What does that mean? They're the solution. They're correct. So now we can put them in. What? Sure. What part are you getting stuck on?
I can't figure out what goes into both negative 40 and 30.
Okay. Read your quadratic.
B squared.
B.
Yes.
Okay. B squared.
Plus 3b
Okay.
minus 40 equals 0.
Okay. Did you make your boxes? No? Box times box equals negative 40. It's a harder number because 40 has lots of factors. It does. It has 1, 2, 4, 8, 10.
Oh, yeah.
Oh, did I not say 5? 1, 2, 4, 5, 8, 10, 20, 40. It's a lot of factors. Let's list them. 1 and 40, 2 and 20, 4 and 10, 5 and 8. I think that's it. Now, I could list each of those pairs again and play around with the positives and negatives.
Can I do positive 8 times negative 5?
That's it. Yep. Yeah, sometimes if you just take a look at all the pairs and you go, well, I need one of these numbers to be negative, which one will work so that when I add them together, I'll get a positive 3. And yes, so we'll use the 5 and 8, we'll make the 8 positive and the 5 negative. That will give me a negative product and a positive sum. So there you go, you got it. So you have B minus 5 times B plus 8 equals, 0. So B equals what?
Negative 5.
Okay, what do we do after this? I was skipping a step. I thought we could, but I'll back it up. Don't skip. Okay, no skippies. Yeah, yeah. What do we do from here? Combine them? What do you mean combine them? Huh? Well, what's the next step? Can anybody help her? What? Plug them in the problem. Plug what in? Isn't that the answer? This is the factored form of this quadratic equation, but it says to solve it. What are we solving for? B, yeah. How do we solve for B using a very interesting property that we just learned about? What property did we learn about in this lesson?
I know.
Starts with a Z. Yeah. Yeah. How do we use the zero product property to solve for B here? Yep. And how do we set that up? Can you look at your notes for like what? B minus 5 what? Yes. Set this factor, b minus 5, equal to 0. If one of the factors needs to be 0, set one of the factors equal to 0. And go ahead and set the other factor also equal to 0, so we can find out both versions of b that will work. What does b equal? Okay, we're going to solve it algebraically. B minus 5 equals 0. Let's get b by itself. What do we do? Add 5 to both sides. B equals 5. Notice how when something's being like added or subtracting, b is just like the opposite of that number. Can you see that? If you want to write all that out, I love it. You know how I love showing all work. But if you ever get to that point where you're like, well, b minus 5 is 0, then b has to be 5, I'm okay with that too. Okay, over here, you can do this in your head, or you can solve algebraically. What would you like to do? Yeah, b is -8. There you go. You know I don't like to skip steps, but in this case, if you're comfortable with doing that, I'm okay with it. That's it. I mean, we could check it to solve, but I would like to move on to number 4. I mean, we could check it, plug it into check. But this one is, oh good, there are 2 parts to it. You got one of these things. Oh, and then when you pop it out, it covers up the question, so that's not helpful at all. It says the total area of the figure to the right is 360. Oh, why don't I erase this first? The total area of the figure to the right is 360 centimeters squared. Use this fact to write an equation involving x. Then solve the equation to find the value of x. Okay, so they're telling us, I'm going to pop this out over here. They're telling us that the area of the whole thing, the whole area is 360. So area, I'm just going to write over this, don't worry about this picture. Area equals 360. This is a rectangle, right? So, what is the formula for area? Length times width. So the length of this entire rectangle times the width of the entire rectangle will equal 360 centimeters squared. So let's call this the length right here. From here to here, we'll call this the length. And then from here to here, we'll call this the width. So let's focus on our length first. Does it give us an exact value for the length? Does it say from here to here it measures 25 centimeters or anything like that? Does it give us information? No, it does not tell us what the length is with an actual number. It gives us pieces of a puzzle that we can put together to represent the length. What are those pieces of the puzzle that we can put together to represent that length? so we're looking for the length or the distance from here to here. Is there other information in this picture that we can put together kind of like puzzle pieces?
16 plus x.
Yes, very good. 16 plus x, because you can see that this length consists of this and the rest, which it gives us the 16, which is super annoying because it doesn't really, that's confusing, right? How there's like a little bit of a border there. That's weird. But anyway, it's saying that essentially from here to here is 16. And then from here to the end is x. It just shows you in a different spot, but since it is a rectangle, there are right angles, these are parallel lines, this value of x, whatever this missing number is the same as the distance from here to here. So we can use this as like a little puzzle piece to bring the 16 centimeters and the x together to make this length. How do we write that? No, how do we write the length?
Oh, 16, centimeters.
We don't have to write the centimeters. 16, how do I represent the length? What?
16 plus x.
Yeah.
equals,
We'll pause there. All I'm doing is saying that the length from here to here, I can't give you an exact number, but I can say that the distance from here to here is 16 and x, whatever x is. So 16 and x. And since the length is being multiplied times the width to get the area, I'm going to put it in parentheses and it's going to be a binomial factor. So how do I represent the width? Again, the width from the beginning to the end, we don't get, or we're not given an actual exact number, but we can represent the total width using information in the picture. Emily, how do you think we can do it? Emily, L. No idea? Okay, so if I say, well, I don't know the whole width, but I know that a good part of it is from here to here, could you tell me what that part is? Good, but that's not the whole thing. What's the rest of it? Huh? Yeah, x. It says from here to here is x. I can just slide that down these two parallel lines and say that this is x, this is 14, so how can I represent, what? 14 plus x, very good. Now, the order of these terms in the binomials, there's nothing wrong with them at all, but in terms of binomial factors for a quadratic equation, I want to use a property that's going to help me flip these, so I can have my variable terms in front. It's just a nice way of organizing it. What property am I going to use? What? No, not the zero product property. That we'll use that in a little bit. But first we're going to use commutative property of what? Addition. We're going to flip these. X plus 16 times x plus 14. It just is going to make it nice and neat when we actually FOIL this and get our quadratic equation. So let's FOIL it. First, outer, inner, last. What are my first terms? We're going to have to speed along here. So I got to go read. X squared. Okay, outer. 14x. Inner. 16x. And then calculator. 16 times 14 equals 224. Positive 224 equals 360. But there's a problem here. Well, these can be combined. We'll simplify that. X squared plus 30, 30x plus 224 equals 360. This quadratic expression isn't set equal to 0. We need it to be set equal to 0. How do I turn this 360 poof into a 0? Subtract 360. Okay, so this is going to cancel out to 0. I need another place to write this. This I can combine. So I have x squared plus 30x, and then I have 360 minus 224 equals negative 1, or I should say negative 360 plus 224 is negative 136 equals 0. You guys can go. Wait, do you want me to finish this?
Yes, please.
Okay. Are you guys getting the same numbers as me? No. Oh, I wish you had the same number. If you guys want, just solve this with me, and then you can just email me to remind me to give you 100 on this homework. Okay, and you don't have to solve it on your own. Okay, so now we can factor this, which is going to be a pain, because do we really have to find the factors of 136? That is such a pain. All right, 136 divided by 2 is 68. That's not going to work. 136 divided by 3. No, that's not even divisible by 3. 136 divided by 6. Nope. 136 divided by 9. 136 divided by 8 is 17. That still doesn't work. 136, does anybody know?
Yeah, you can go.
Oh, you can go. 136 divided by 12? No, that's not going to work. Why is this not working? 360 minus 136. I'm having trouble finding factors here.
Yeah, me too.
You are too?
I'm trying to.
Yeah. I hope this isn't a mistake. 136. 136 divided by 3. 136 divided by 4. Oh, I got it.
What?
It's 4. It's 4 and I guess I skipped that one. 136
Oh, you're right.
can be broken up into 4 times 34. To make it negative, one of these has to be negative. To make this positive, it's the 34 that has to be positive and the 4 that has to be negative. That is so confusing. Okay, so 34, so we would have x plus 34 times x minus 4. Set both of those equal to 0, you'll get x equals negative 34, x equals positive 4. But here's the kicker. If we get solutions of x equals, yeah, you can put it there, thank you. X equals negative 34 and x equals positive 4, and I need a dimension for this distance, will both of these work on negative 34 centimeters? Or which one's going to work? Yeah, only the positive version. So this is the answer. That's it. Yeah, you're good. Just email me and say I got 100 on homework 8.2.
Wait, what about part 2 though?
No.